Okay, thank you for joining us today. For those who don't know me, I'm Adam Chain, Executive Officer of PLA Queensland. We're very excited today to have our friends from SportEng join us for a webinar, Demystifying Natural Turf Fields of Play. And we have John Nealon and Jared Hill in attendance, which is absolutely fantastic. Before I get started and share a bit about the team and what they're going to discuss today, I'd just like to do a welcome to country and acknowledge elders past, present, and emerging, in particularly on the lands that I meet today, are the Gubbi Gubbi lands, and acknowledge the lands in which you meet virtually across Queensland. And also we have some guests from across Australia, which is fantastic. I'd also like to acknowledge that it's NAIDOC week this week as well, and there's some fantastic events and opportunities to celebrate in the week for those who are interested. So definitely a great celebration this week for Indigenous culture. So let me get started to the good stuff about the SportEng crew. So for those who don't know SportEng, they are a civil engineering company and turf agronomy company which has a passion for sport and high quality fields of play. They have offices in Brisbane, Melbourne, Perth, and they're also opening up in Sydney in 2021. So they have an exemplary footprint across Australia. They're known and I would say, one of the best in field of play in Australia, and I've dealt with them across my time, both professionally and through PLA. They've developed many projects across Queensland, and one of the big ticket items is the 2018 Commonwealth Games and the athletics track and beach volleyball facility. They've looked after Country Bank Stadium and the Gold Coast Suns training oval and part of the redevelopment of Metricon Stadium. So they've got some great insights into both elite elements, but also have a lot of experience in the community parks and play spaces as well. Today's session is going to be interactive at the end, but what we'll do, we'll just start with John and Jared basically sharing their great insights, and I really hope you learn a lot like I will today. And feel free to contribute to discussion at the end. If you have any questions during the session, just reach out either to me privately in the chat or just put in the chat bar, or just hold them for the end when the team finish, and we'll most definitely share in it. We've set aside an hour for today, but for some reason, if we run over, if you want to keep the discussion going, I'm sure John and Jared can take some follow-up questions or stay on the line, or we can also look at filing up different elements of the session at a later date if there's all real juicy bits you want to get through. So I just want to introduce John first. John's one of the most prominent turf agronomists in Australia. He has extensive experience in undertaking research and consultancy with a wide range of clients, including golf, sports field, racetracks, and local government, and has expertise in soil, drainage, water management, turf grass selection and evaluation. And Jared is the CEO and Director of SportEng, leading field of play consultant, and designed many facilities across Australia, particularly the ones in which we spoke about in Queensland environment. Especially a specialist interest in civil engineering and applications and detailed understanding of athlete and facility owner requirements. So if you have any of those kind of juicy questions on the back of your mind from the community level through to the elite performance area, feel free to share. So I'm going to basically turn off my mic and video, so pass over to Jared and John and sit back, enjoy, and enjoy the discussion. Thank you all.
Morning all, and thank you for your time this morning. As Adam mentioned, my name's Jared and I'm the CEO and Director of SportEng, and along with me today is John Nealon, talking through the work we do. I guess, as Adam alluded to, one of our overarching principles is high quality design work, and we try to apply that in everything we do. And it's, again, the principle is just doing it right the first time, and not having to come back and retrofit something that has gone wrong. So I guess what John will be and I'll be presenting on today will be some of those principles around the natural turf profile and some of the associated infrastructure. And then also at the end, we'll just also touch base on some environmental design options that could be considered, which will help make your facilities a little bit greener, not just in colour, but in an environmental sense as well. So I'll pass over to John now to sort of start through the natural turf perspective.
Okay, thanks, Jared, and good morning to everyone. In the years that I've been involved with turf, across research, consulting, and also education, I've inspected and audited a lot of sports fields across Australia. For quite a few years, I was doing the audit work for the Australian Football League, which was sort of looking at community fields at the elite level, which is a challenge in itself. And last year had the privilege of looking at some sports fields as far north as Weipa. We've done work in and around Townsville, and I think it's already been mentioned that we've been doing some work with North Queensland Cowboys, and also over the years done quite a lot of work both in sports fields and golf course work in and around southeast Queensland. So it's an incredibly large state, and it probably highlights one of the things that we're very conscious of when we're looking at sports field design and construction, is trying to get a good understanding of the local environment, and also to have a look at some of the possible restraints on what we may wish to design versus what we can do practically, but always looking at coming up with something that's going to be fit for purpose. Looking at Queensland more broadly, high rainfall events is always one that comes forward. Having systems that drain well is a critical factor that we look at from a design point of view. Cost of water is becoming more of an issue, particularly in the southeast Queensland area. And water quality, which is something that brought me actually into the turf industry 35 years ago, continues to be a regular challenge, understanding of how we can use reclaimed water, probably lower quality bore water and storm water sources, while maintaining good quality playing surfaces. And it seems to be a bit of an Australia-wide thing as well, that the availability of suitable sands and gravels is also presenting somewhat of a challenge. So just onto the first slide and sort of having a bit of a think through what we're looking at, particularly around performance. It's a function of a multiple of factors. Quite often we find projects that maybe get hung up on one particular element, but we want all these elements together. There's the soil selection and soil management. There's the surface shape, because we still rely to a certain degree on surface runoff. Drainage design, whether it's the subsoil drainage system, whether it's the stormwater system that's going to take water from the site, or even installing sand slit drainage systems into existing fields. So it can cover a multitude of factors. Irrigation is absolutely critical at a time when people are very conscious about water use and water use efficiency, particularly if water quality is not great. A high level of irrigation design and water application efficiency is highly desirable. We've got grassing. There's a multitude of grasses available, and I'm not really going to touch on that today. That's a seminar in its own right in terms of the quality aspects of different grass varieties and species. While we can do the design, it then becomes a quality of construction that's really important. So we have a strong emphasis on the quality control procedures, particularly around materials coming into site, sands, gravels, and also grass, to make sure that the construction actually meets the specification that we put forward. And then there's the ongoing maintenance, which can be a bit of a challenge. I know with a number of community fields, sometimes there's a little bit of a disconnect between the group that are putting the project together and the people that are going to have to take over and maintain that facility. So we do have a strong emphasis also on putting together operational manuals as well for that project, so that it can be maintained to a standard that's going to protect the asset and you're going to get optimal performance out of it. So because my background is originally soil science, and the more I've looked at turf and sports field construction, golf courses, racetracks, whatever it is, the soils are very much the foundation for high quality turf. Probably the vast majority of projects that I see that fail, it's usually a failure around the soil selection. Now, we want our soils to do a number of things. It's got to hold some water for us, and that's becoming a bit of a pinch point in terms of, particularly with sandy soils. Are we going to hold enough water we're going to have a site that's going to be a little bit difficult to manage from an irrigation point of view. We need a high level of soil aeration. As you can see on that slide on the right-hand side there, we want a deep root system so that we can exploit moisture from the full depth of the profile. Now that's going to be in part affected by the aeration porosity of the soil that we select, but also how we manage our irrigation as well. We want a well-drained profile. We want one that's going to resist compaction. We want a profile that'll support our good, strong root growth. We want some nutrient storage, but that's probably a bit of a distraction at times. Sometimes we just have to accept that we have to modify our fertiliser programs to meet the requirements of the particular soil type we select. And of course, it's got to be suitable for the playing surface. We've got to be very careful around having sands that are, say, too coarse, or soils that are too coarse and become very unstable when they start to dry out. Conversely, if we have sands or soils that are too fine, surface hardness can become a real issue. Now, this is becoming a very important issue at the elite level, but it's sort of filtering down through to community levels as well. So we found across the periods of drought that we've had, quite often fields have become dangerously hard and aren't suitable for play because they are just too firm. And that's often a relationship to soil type, but also, of course, moisture retention as well. So if I was going to pick one single element out in terms of when we're looking at our soils and what we're trying to achieve, drainage is very much a key criteria, and then followed by moisture retention. So one size doesn't necessarily fit all, and over many years of, again, having to deal with multitude of different clients, different localities, we can't necessarily have one template that's going to fit all circumstances. And often we need to ask ourselves the questions, what are we looking for? Is it going to be a high use facility? Do we need a firm surface? Has it got to be fast and bouncy like for a cricket wicket? Do we need it to be well drained? And of course, this changes a lot depending on what the actual sport is. When we're looking at sports fields, good drainage rate, good grass growing conditions, good drainage tend to be our key parameters. And usage. That's a question that's often asked, particularly in the local government area. What's the projected usage? Now, for new sites, greenfield sites, new subdivisions, often the early usage is going to be quite low, but sometimes we need to be able to project forward and start to think, well, as this area grows, the usage increases, what sort of numbers of hours per week can we likely to expect? So that takes a little bit of work and probably a little bit of thought in terms of projecting into the future, but it does help in terms of finally understanding what's going to be constructed so that it's going to sustain that level of use. And at the bottom of this, they're sourcing appropriate soils and sands. That is, again, a challenging one. And Queensland is certainly in that category, that what we've had to utilise at times doesn't fit what we consider to be the perfect scenario as to what we might read in the books. But we look at some very key criteria around drainage, moisture retention, so that we're going to create good growing conditions for our turf, even if ideally it doesn't fit the book, what you might read in the book, but it's going to be the best material that's available locally, because obviously there's going to be cost issues as well. So with our profile options, we've probably seen a number over our lifetime, and we've seen a number that fail. So our soil-based profiles, our sandy loam profiles, have often been the stock standard for probably the last 30 or 40 years. We've moved more and more into sand profiles, and they have different levels of sophistication. We've got our sand gravel profiles, which is sort of our elite profile, more conventional sand profile. We're starting to do more sand carpet, and I'll talk a little bit more about that from a Queensland concept. And then we're getting into the very high level fields where we have reinforcement integrated into the profile, and also hybrid turf systems, which are a combination of natural turf and synthetic fibres. But we won't be concentrating too much on that today. We're happy to answer some questions in and around those particular applications, but we're going to sit more with what we would typically be looking to design and construct from a conventional or from a local government perspective. I just wanted to show this particular slide, and hopefully if I can get hold of the laser pointer, I can point to a few things. We did some research a number of years ago where we intensively analysed and measured a whole series of parameters on several different sports fields that were constructed of different soil types. And I often throw this graph up just to sort of indicate where we're trying to head if we're going to have high hours of use, the importance of a well-drained profile. Our SP1, our sand profile here, had 800 hours of use total across a 6-month winter period. Each field was actually given a rating based on its drainage capacity, recovery from wear, the quality of the surface. So across that year, it had a rating of 80 out of 100. So it points pretty clearly and fairly logically that a sand profile is going to give us our best hours of use across high rainfall periods or across the winter months. When we have a look at our soil profile, we're getting about just under 500 hours of reasonably useful use, rating very low, 30 out of 100. This particular field, it only needed 1 weekend of a lot of junior activity with wet weather to completely destroy the field. So its use under those soil conditions was quite limited. This field was actually in the same complex, soccer field, used for a 2nd tier soccer competition. So it needed to be in reasonably good condition. They were very limited in the hours of use because the drainage capability of the field was actually quite poor. So it rated reasonable from a quality point of view. So I just want to highlight those 3 in particular, from sand through to soil. And if you want to maintain a surface, how limited the hours of use are going to be. So just working through a couple of the options. The sandy loam soil profile, it's interesting how it's typical of older council fields, but we're actually seeing some councils defaulting back to that type of soil type. The basis of their thought process has been really more around we want to hold more moisture, so we need less water for irrigation purposes. Now, that is another whole different discussion. I've written a few papers on it in the past. It's not really quite accurate, okay? So what we're doing is that if we have a sandy loam soil, we've got something that's much higher in silt and clay. It has poorer water infiltration and drainage. So one of the really key criteria of having a high level of playability is lost. Subsoil drains are quite ineffective because it's not possible to get the water down through these siltier clay type soils and taken away efficiently, unless it's combined with an extensive series of sand slit drains. So the hours of use are around about 10 to 15 hours per week when dry. But as you can see from the slide, the picture on the right-hand side there, they can turn to mud very quickly. So what happens is we start to lose the quality of the game, the skills are affected, and this is something that often comes back from the user groups, where they're trying to teach the skills of soccer or rugby or AFL. If they've got poor quality fields, it's very difficult to enhance those skills. So hence we're looking for much drier profiles. Our default sports field profile is sand-based. So we've got excellent water infiltration and drainage. We've got good resistance to compaction. We've got really good growing conditions for our turf, so we can get a really good, deep root system developing. One of the negatives that's put forward a little bit is nutrient leaching, probably the main management challenge. I think that often conflicts a little bit with the selection of fertilisers and often a movement towards high price products. So there's a budget limitation on how much fertiliser you can put on, but don't necessarily compatible with a sand profile. So again, that's another area of management and how we can maintain these fields with lower cost fertilisers with a little bit of a spoon feeding approach. So sometimes it does take a little bit of change in management strategies, how these profiles are maintained to optimise their performance. Low water holding capacity, again, is often thrown up as a negative. It's droughty, it's going to need more water, etc. That perception is really not quite correct. We need to understand the principles and irrigate accordingly. We may need to irrigate more frequently, okay, but ultimately the total amount of water that the grass requires, whether it's on a sand or a loamy sand or a clay, is exactly the same. The plants are going to use the same amount of water. It just changes the method by which we do our irrigation. And having done a lot of irrigation audits, we find that the control systems are very much locked in to a time-based system, which are quite inflexible. So we're not actually optimizing our ability to get water deep in the profile, generate good deep root systems, so our grasses are exploiting that moisture deep within the profile. Typically, we would expect 20 to 30 hours a week of use in the Queensland environment, and particularly as you go further north with extended growing season, that could be 40 hours plus. Again, takes a little bit of careful management and thought in terms of those high traffic areas, but the high use factor is very, very good, particularly with well-drained profiles. Combination of saturated conditions and high use causes rapid turf deterioration. When we get to our more elite level, our sand-based, what we call our perched water table profiles, that's where we have a gravel drainage blanket over our subsoil drains, and then we have sand over the top, so we have excellent water infiltration and drainage, so it's highly efficient. The perched water table, which is, we tend to get a little build-up of water at the interface between the gravel and the sand layer, and I'll talk a little bit more about it in the next couple of slides, which actually helps store water within a sand profile. So it can increase that water storage by about 30 to 40%, okay? It does require deep irrigations to recharge that little perched water table, but it's a positive factor in this type of system. We have good resistance to compaction. Nutrient leaching can be a little bit of an issue, but where we've probably found these profiles to be very good, not only for elite usage, but also on capped landfills, or where we've got contaminated soils where you're not allowed to excavate into those layers. So we can actually use flat drainage pipe technology, gravel layer over the top, and then our sand backfill without intruding into those soils that we don't necessarily want to have to deal with. I've put up sand carpet profiles because of cost restrictions. There has been a tendency to work towards more shallower sand profiles. I'm not totally convinced that they're suitable for Queensland, but just putting it in there just as by way of an example. We've had to do some work in sort of northern New South Wales. We've had some restrictions around site conditions and also budgets. So we can create a shallower sand profile, but it needs a very high network of subsoil drains, sand slit drains. So in this example, we've got a lot of sand slit drains. They're at 2 metre spacings. We've got a sand capping layer, which is about 100 millimetres thick, then our turf on top. The main reasons they are lower cost, because you're using a lot less sand in the process. They're very good for difficult sites. So we've implemented these in sites where they might be flood-prone areas where you're not allowed to change the site levels at all. Also in places where there might be something like acid sulfate soils, and certainly having done work in Queensland, acid sulfate soils seem to be something that pop up quite regularly. Also for sites, again, where there might be contaminated materials that you don't want to excavate into and have to dispose of. They are a shallow profile and might be a bit more challenging to maintain them from an irrigation point of view in the Queensland environment. They are a specialist build because there's a lot of drainage works that has to take place and requires specialist equipment, and they have pretty good hours of use. So while it may not be completely applicable, it would always be something we would probably consider depending on the site conditions up in the Queensland region. And just last couple of slides here around sand selection and sand depth. Sands can be challenging to get the right sand. Not all sands have the same physical attributes, and we must test. And quite often there's a selection of sands. People will select sands, bring sands to site, but there's no testing to support whether it's going to serve the purpose or not. So we always recommend testing for particle size, moisture retention, aeration porosity, drainage rate, and then during the construction process we have a very detailed quality control program where we're testing every 500 cubic metres of material that's going to come into that project to make sure that what's specified actually comes to site, and also reinforcing that this is a specialist area of testing and it's important to use an accredited laboratory, a laboratory that's got a track record of dealing with materials for Sportsville projects. Again, one of the challenges across the local government area that we've found, and particularly where budgets are a constraint, sometimes there may be an arbitrary decision to reduce the depth of the sand profile. Okay, so every sand type has its own particular characteristics in terms of moisture retention, aeration and drainage. Now, if we have a particular sand and it's in too shallow a layer, what happens is that what we call this perched water table, which is at this interface, say, between the gravel layer, or it could be the subsoil, and the sand, there will be an accumulation of water. This is a natural occurrence, and every sand will have its own characteristics. And it creates what we call a capillary fringe. It's a bit like blotting paper in water. Water actually moves upwards into the profile against the forces of gravity. Now, if the sand happens to be too shallow, we find that this capillary fringe, or this rise of water, starts to intrude into the upper root zone, which is undesirable. So comparing with our figure 2 down here, where we've got our optimal profile depth, our perched water table is sitting down at the lower end of the root zone, so the roots can draw on that water, but they also got very good aeration in the upper part of the profile. So shallow profiles can be wet profiles. Now, if circumstances dictate that we could only have a 150 millimetre deep profile, maybe because of cost, we have to make sure that we look for a very specific sand type to make sure that we avoid this lack of good aeration and water movement up into the upper root zone. So we don't want to make arbitrary decisions on the depth of the profile. It has to relate back to the sand selection and doing our testing and our homework before we finally specify a particular project. Okay, I think that's pretty much all for myself. I'm going to hand this back over to Jared, and he's going to talk a bit more about the supporting infrastructure.
Yeah, thank you, John. Yeah, so now I'll just talk through two of the key infrastructure elements that support the profile, being the drainage and the irrigation. So drainage, the principles around drainage is pretty straightforward. It's effectively removing the surface from the water from the surface. So you want to get the water away from the crown of the plant, away from the foot traffic, so that you don't damage the plant. So as John was alluding to, if you select the right profile, that water will infiltrate through that profile, and then you're looking at collecting it in a subsurface network. The image to your left is what John intimated earlier around a perched water table with the Mega Flow flat drain system. So it's a trenchless installation there at Perth Stadium or Optus Stadium. So again, avoiding the need to do any trenching work, it becomes a very easy and quick installation. And then the image on the right is probably something you're more familiar with, which is the Metricon Stadium, which is a subsoil trenched installation, which is obviously a little bit more time consuming, but it's just equally as effective. The second part is probably one of the most important ones of the two, is around the efficiency of the irrigation. So having an irrigation system that accurately distributes the surface water, distributes water across the surface evenly and can be controlled. So uniform coverage, one of the key things we look at is particularly around the head-to-head coverage. So the fact that you can the sprinklers throw from head to head. Uniform pressure and flow is critical to maintain that uniform coverage. Flexibility is something that's often overlooked at a council level, for the ability to have quick coupling valves around the areas to might be irrigate particular areas due to high wear. If you don't have a valve in head, you might need a more localized control system. So having quick coupling valves allows that readily access to water in localized areas, and might be a separate system around the wicker block. As John mentioned in his presentation, but the ability to control these, the technology is there. You can control it from sitting at home. Obviously, it helps to get out there and see the efficiency of it. But the technology is there for you to use. And then signs of poor irrigation. This here is a critical element, image that we see time and time again, whether it's through poor design, lack of pressure and flow, but those UFO types shapings that really show the inefficiency of the system. And one thing in relationship with going back with John's relationship with the profile, having moisture sensors is something we really try to emphasize with clients. It's not just something that is used for elite facilities. Having moisture probes built into the profile where you can monitor your application and the depth that it's getting into. As John said, if you do go with the sand profile, you're looking at trying to get some deep irrigation and retaining it at depth so you don't lose it through evapotranspiration. So having that, the ability to monitor that moisture in your profile is key. And I'm just going to step through a couple of sustainable design options that could be considered in your designs, so that could complement it and really make a positive outcome for the environment. I guess everything, when we start talking in the environmental realm, is nothing comes easy. It usually does come cost, or it's a new technology that people need to understand. But once we make that step change, you start to see that value and return to the effort. How to green your natural turf field of play. Sometimes it does challenge the status quo, and I know John's butted his head up against numerous curators along the way who are stuck in their ways and have continued to do things because that's how they've always done it. A lot of things that John's mentioning and things that we can mention in regards to the maintenance side of things, it's not new. It is readily used. Challenging what is being done sometimes is one of the first hurdles to get over. They're simple. Some of these things are quite simple to include that can improve the outcome. They do have a proven track record. It's all about being eco-efficient, so finding ways to be efficient and in the way that you're applying, designing, constructing, what it might be, but there is way. It's all about being efficient in your application, and not just. And there's one slide I'll really emphasise in thinking outside the natural turf field itself. There's other ways that what we do on the natural turf field of play actually has a greater impact on society. The image to your right, I'll just touch base briefly. That there shows the perched water table. You can actually see that there. This is out again of Optus Stadium during construction. You can see the moisture there. I saw Tony Hemming dial in earlier into the presentation. So, Tony in the early days, I assume would still be doing was monitoring the moisture and maintaining that moisture level down at that depth there. So you can see the moisture was hitting down there. I've just dug down to just on top of the drainage gravel layer there, so you can see that reservoir being built up. one of the key things I did talk about earlier was around your irrigation. So having an efficient, targeted and quantifiable irrigation network. As John alluded to, turf is an organic element and it requires the same amount of water regardless of profile, drainage, whatever. You have an organic element that has a need and a desire for so much water. So what you want to do is install and design and construct a system that efficiently that water. So whether it be through a design similar to the one on the right, which was a targeted banked system. So again, targeting zones, or if you've got the ability to, or the funds to apply a valve underhead system where you can control each individual sprinkler. So there's different ways of applying it, but having some thought and process around how you target those zones rather than just a simple installation, which might be just lines from a perimeter ring main. Strong level of control, again, it links to those ability to target where you're applying it, but also knowing what you're applying and having quantifiable. Again, if you've got a sand profile or even a perched water table, being able to monitor the application and only need to top it up when you need to top it up. Again, technologies out there that you can start monitoring your rain events and knowing how much is falling on your field, and then you only need to top it up rather than doing your normal application. Too many times we've had conversations where groundsmen will just apply 10 mil 2 times a week or whatever it might be ritually without even really thinking about what they're doing. It's challenging, as I said earlier, that status quo, that mindset of let's give it what it needs. Cooch is an amazing turf where it does actually exceed under a little bit of stress. So you don't want to make it too lazy and give it everything it needs all the time. You do want to put it under a little bit of stress so it does react and look for that grass and send those roots down, look for that water and send that roots down nice and deep. And use technology, as I mentioned earlier, having those soil probes in the profile, which is that image at the bottom there. We often specify a 3 metre long probe because often if you've just got one of those small spot probes, you may not be getting the true representation of the profile. So having a longer probe really gives you a good feel for the moisture in the profile. Something we've been doing a lot is trying to understand what you've got before you throw it out. So whether it is, as John alluded to, doing some testing of your existing growing medium to see what it is and whether you can utilise it. So this is harvesting soils at Lathlane Oval, which is a West Coast Eagles training field. We identified the existing soils on site could be readily utilised as the growing medium. Similarly at Fremantle's training ground, we did the same where we actually had to stabilise it because the soil was a bit too rounded in particle size. But understanding what you've got and seeing if you can use it before you do throw it out can obviously be a good, sustainable outcome. This is an interesting project that SA Water have done for the last couple of years over in Adelaide. Initially, it started off at Adelaide Airport, and then they moved to testing the ambient temperatures around their sporting fields. So that it started, as I mentioned, it started at Adelaide Airport, and they wanted to see if they were to irrigate their green fields around their runways, what the efficiencies of the overall efficiencies to the greater environment would be. And they found that by having greener, having their grass around the runways green, they helped lower the ambient temperatures by about 3 degrees, which actually optimised mechanical operations, not only of the planes, but of also the air conditioning within the adjacent takeoff lounges. And then that South SA Water started looking at that further and thinking, okay, how does this impact the community? And they started putting all these heat sensors around the community and adjacent to natural turf fields, synthetic fields, acrylic courts, hard standing, and trying to understand on certain days what the implications of having well irrigated fields were. And obviously in the Queensland market, you've got a lot hotter areas. And similarly to WA, which is another project we're working on, which you can see Maniana Park at the bottom there, the image to the left is a well irrigated grass field. And then Queen's Park is an unused green space, heavily exposed sand at the surface. And then you can see the heat island effect and the flow-on effect of the heat from those sports fields. So Maniana Park, well irrigated. You can see the cooling effect that has on the residential zones adjacent to it. Whereas Queen's Park, sand gets very hot, reflects the heat, and you can see the downflow of that, the downwind flow of impact of the adjacent areas. So again, it's sort of thinking outside of where you're at, not just the field of play, but seeing how that can have a positive impact on society and the community around it. Finally, something we hear a lot in certain regions is around the value of independence and the advice sought from either sales representatives of product lines. Obviously, know what you have, and then you know what you need. So as I went back to saying around with the sands, whether you can reuse the sands, know exactly where you're at with your natural turf field of play, the health of the turf, or what the infiltration might be, so then you can know what you need to improve it. Often you might be told one thing when you don't need it. So understanding that, and there's ways of understanding that information through ongoing testing, either through performance testing of the surface, so physical testing of infiltration rates, traction, or even just the visual observation of the turf coverage, and then you can get turf health checks on the grass itself. Take samples of the grass leaf and testing the health. Knowing that information then helps you understand what you need to apply to get a better outcome. And the right advice can save you a lot of time, effort, and money. And I think the effort's probably one that is often overlooked. Time and money are probably self-explanatory, but the effort sometimes to apply these things where it may not be needed can be time-consuming. So, as I said, understanding what you've got, seeking out that independent advice is critical. So I'd like to wrap it up there. Thank you for listening this morning. I hope you've got a lot out of it. Obviously, John's initial overview helped to provide some understanding of the natural turf profiles, and then I've provided a little bit of information around the supporting infrastructure and some sustainability items. So thank you again for listening.
That was great, Jared, and thank you, John. Very insightful from my end, and just even early on in the opening remarks about the challenges of multi-use and utilisation I know is a very, very massive challenge. A lot of sport and rec planners trying to resolve through master planning or field allocation, and yeah, that interesting point about Adelaide Airport with the green grass. The experience is phenomenal, your team. So really appreciate you taking the time to share with the group. Now we've got 15 minutes for questions. I've just got a couple that have come through just private message, and then I just see one as well that's just come from Craig. So I'll just start with ones that are just backed up, if I may. The first one is, if we have to do design fields based on specific sports, how do we manage multi-use fields, i.e. different sports codes on the same fields? So for example, an AFL and a soccer pitch, for example, blended together. Got any insights on that, team?
You want to have first crack at that, Jared?
Oh, I mean, yeah, I mean, it's a difficult one. The relationship, historically, the relationship has always been AFL and cricket, and there's obviously a nice handover between those two in a seasonal sense. And they do have their performance requirements, so there is a transition period between the two. I guess, as you alluded to, the inclusion of soccer into the mix now, where we often have maybe two soccer pitches with an AFL oval or cricket oval overlay, it does start to make those design challenges. A lot of the principles are still relevant that John was alluding to. You still want the profile to perform in the sense that you do want the water to drain away as effectively as possible. What you're looking at potentially is around the hardness of the ground as well. So AFL developing that thatch layer and having high moisture contents that help create a softer feel, whereas soccer predominantly likes a harder, faster field underneath. So it comes down to, as I said, the same principles from a design. It then comes down to maintenance and how you actually curate it. John, do you have any more to add to that?
Yeah, I was going to jump in there. It's interesting, this project in northern New South Wales, that's sort of a multi-use, multi-sport complex. Another one that we're just being finished doing some technical reporting on in Sydney, are based around sort of soccer. Jared sort of pretty much spot on there. You've got to look at the individual sports and their specific requirements. And then it's a matter of how you manage the workload around those fields, particularly around sort of goal squares, centre bounce areas, or the centre kickoff areas of fields. And I know that it's a constant source of frustration for agronomists like myself, and also the ground staff, engaging with the user groups to understand that they're not the only group involved. I know that takes a lot of work and a lot of discussion, but it's one that's well worthwhile having, I think, so that everybody respects the facility and protects the asset. Because what it does, it'll do a couple of things. One, it'll reduce the repair costs at the end of respective seasons, or if the seasons are overlapping. But it'll also make sure for better quality surfaces. Again, it just takes a little bit of communication and working through the specific needs and managing that usage and engaging with the clubs. I can't overemphasize that enough.
No, great. Thank you for that one. And the next one's regarding more contamination of land, and a common thing our industry has is sport fields built on old landfill sites, and the obvious constraints that come with that. The question is, can these soil profiles be improved in a cost-effective manner, or are we kind of just stuck with the challenges of contaminated land and the duration, I guess, in which the land's been contaminated and with whatever sources over its many decades?
Yeah, I mean, John touched on it earlier days. You know, you've got, with contaminated ground, the last thing you want to do is excavating into it. So it is around avoidance often in those profiles. So if it's a landfill, there's a requirement to cap that landfill and prevent any trenching into that profile. So that's when we do look at a perch water table profile that allows you to have trenchless drainage and irrigation. That does add a cost to the overall project because it moves away from being a minimal 250 sand straight profile with trench surf infrastructure. So you are looking at an increase in cost as a result of that. And we can play around with the depth of that gravel to minimise the depth in the cover, but it comes around constructability. You need to have enough rock cover over your pipes that you install for protection of those assets. So there's not a lot we can do to keep the cost down other than avoidance of the contaminants, I guess, is a big thing, which keeps costs down. So it's probably more avoidance than anything when dealing with land development sites.
And I think we've had this discussion quite a bit on a lot of new construction works which are going out into different land. They're trying to utilise whatever spare space there is that you can't build houses on. So very reactive soils is something we've had to deal quite a lot with. We've had to have projects where we've had to put in capping layers to provide a stable substructure. But we've also faced the prospect of building profiles in less than ideal conditions and then trying to have a maintenance program that will counteract to some degree the differential settlement you're going to get, so through top dressing programs. But then you've also got your other infrastructure you've got to worry about. What's the settlement going to do with irrigation system? If you do have some subsoil drainage in there, what's the subsidence going to do that as well? So they're all the questions that have to be asked and worked through both from an agronomic and an engineering point of view. And then coming up with, I think, the most cost-effective method and the long-term value of what you're going to design and construct. So some short-term sort of reduced cost efforts may prove to be an ongoing nightmare from a management point of view, ultimately resulting in a rebuild some years down the track.
Yeah, no, I agree. And putting my town planning hat on, you have to add the complexity of approvals and regulatory authorities allowing you to do works on those sites as well. So it starts at the policy side all the way through to putting a shovel in the ground. So thanks for your insights there. I just got a couple more that have come through. Craig Nicholas from Synthetic Turf. This is for you, Jared. What are your thoughts on tip over point, if any, from natural to sun turf, and the sun turf issues regarding heat transfer into the community?
Yeah, reading between the lines, I think that's around synthetic turf more so than sun turf. I think Craig's got a typo there, but yeah, it's the introduction of synthetic grass came in. What are we now? Almost 15 years ago now, and it came in as a purpose initially in Melbourne, Victoria, when we had drought. So it really came in as a driver around reducing irrigation. We had areas in Melbourne that had no irrigation on their natural turf fields. So this was a way to get around that. It has since evolved from there as now moving from an irrigation response now to a usability, hours of use. So I guess a tipping point, if I'm reading Craig's question correctly, I get frustrated when clients pull the trigger on a natural field to synthetic because they view the natural not working at a level that they expect it to without knowing why. So if you're ever looking at a natural turf field, first understand why it's not getting the level you want before you turn it into a synthetic. Synthetics are fantastic, particularly for soccer, because in a soccer pitch, you might have 4 simultaneous small-sided grounds, so you're suddenly quadrupling the amount of people on that pitch. But know what you've got before you throw it away into a synthetic. Synthetic has a place in the market when you're wanting to use heavily trafficked areas. But as I said, just because the grass is not performing to start with, there might be a reason for that. It might be simply irrigation. There might just be additional drainage lines cut in. So know what you got before you throw it away. And then, if you're going to hit it with 60 hours per week, that's when you probably start moving into that synthetic realm.
I like that, Jared. I think you touched on it, both you and you talk about understanding what's underneath first and the importance of the sampling of the soil to resolve your issue. And working in the sports sector, before we put a base down, we like to understand what's on it. But natural turf is the same principles, I'm assuming, as well. So thank you for that one there, Craig. Tony Hemming. So, John, what do you think thatch levels range should be for AFL fields?
Thanks for that, Tony. Look, I initiated all the original testing for AFL fields, and as AFL players became more precious and more concerned about surface hardness and conditions of surfaces, particularly when they started to go out into the regions. So, we used to go to Alice Springs, we'd be up Cairns, Townsville, all over the shop looking at sports fields, going out into central New South Wales on community fields. So firmness has always been an issue. That's sort of come through the high performance guys. I suppose monitoring players, their fatigue levels and their recovery. So that's a whole bunch of sort of science and voodoo all mixed together. So we've concentrated a lot on surface hardness using the Clegg Impact Hammer. So that's been our major tool for doing that for a long period of time. Now, throughout necessity, we've added other things like traction devices, soil moisture sensors, NDVI meters to measure turf quality. In terms of the firmness and thatch levels, I think it comes down to understanding what's the relationship between the firmness of the surface using the Clegg, the soil moisture content, and the thatch thickness. Now, it's a combination of the three interacting with each other, because I know from having done a lot of monitoring work at Marvel Stadium, which was probably one of the first hybrid systems that went in, there was no doubt there was a strong relationship between how much decompaction was taking place and the firmness of the surface, so it could be managed accordingly. So again, there's a lot of emphasis on the curating staff to understand those interactions and knowing what the cause and effect is going to be. Because if there's ever going to be a game killer in AFL circles, it's hardness. And once they get it into their heads, it's there forever.
And just following up on that one, and I'll get back to you, David, a question just came through privately. Thoughts on hybrid turf and the use in combination with natural turf, particularly in the use of high use areas such as goal squares? So that was kind of what you were saying there.
Yeah. We've got a number of fields that we've designed in recent times where we're putting the hybrid turf into the goal squares. It probably, look, grass will wear out almost irrespective of what it is and what it's combined with. The good thing about the hybrid turf, say in the goal squares, is that if you lose a lot of the grass cover, particularly on a sand profile, you still have a nice, level, stable surface. So it's, from a safety point of view and a playability point of view, it's sustained through. So we've got a number of councils that are doing that as an option. So centre bounce areas in the goal squares, in some extreme cases, maybe even looking at from goal to goal lines to increase the stability and overall wearability and surface quality.
Yeah, I think it's important to clarify there's a hybrid glass which has the extension of the synthetic fibres through the surface, where you get that combination at the surface of natural and synthetic fibres occurring. Then you've got what we refer to as a profile reinforced system. So you don't have those fibres protruding through the surface. So it's imperative to understand why you're wanting to go down the hybrid path. As John alluded to, if it's just for stabilisation, there is probably a greater range of products you can consider, which, through either mat laid systems or a fibre inclusive blended system. So just understanding what you're needing is probably critical.
No, great. And we'll just finish up with David Mason's question there. This one's to John. Just following up your shared use issue, should shared soccer rugby use of the community level non-elite fields be avoided due to high maintenance costs?
Shared between soccer and rugby?
Yeah.
Oh, they're bad bedfellows, aren't they? Having done some work with a northern suburban council up in Sydney, which had limited playing fields, rugby was the one that just astounded me in terms of the wear and the damage on the field. And I suppose in very broad terms, very poor bedfellows with soccer, probably even at that community level, where you want a surface that's got reasonable stability, doesn't have a lot of localised depressions or chopped up areas which are really going to impact on the game. And we've been working on a number of projects which have been orientated very much around soccer. And when you look through, whether it's Football Australia or the state level, it's the condition of surfaces, the playability, good drainage characteristics, and evenness of surface. It doesn't have to be the perfect surface. They're critical things for soccer. Yeah, so combining soccer and rugby sounds like a very difficult challenge. I don't know what the answers are there, other than, again, pitching a much higher level of maintenance. Have you got any thoughts on that, Jared?
The only thing I would add to that is that that might be a conversation where you look at a profile reinforcement to help prevent that rutting or displacement of ground that John alluded to. So the football requires, or in soccer, football, there's a much stronger relationship between ball and ground, whereas rugby it's a less so. So if you can help stabilise the profile, will help minimise that displacement. But yes, as John alluded to, they're not a good marriage, those two.
No, that's great, and thank you for those who have provided questions throughout the session and partaking in the discussion. And I'd just like to thank Jared and John. Thank you for your time. It's been very insightful. I know a lot of people on the line, particularly what John was alluding to earlier, the elite creeping into a lot of local government areas with AFL coming up to Queensland, rugby, plus the push to community sectors, the traditional sports fields being looked at and utilised in different manners based on load and type of play. So there's a lot happening up here in Queensland, and hopefully a lot of people got a lot to take away from this. Sincerely and gratefully from PLA and PLA community, I'd just like to thank you both for your time, giving it up today. It's very, very, very amazing content that you're able to share, and I'm sure many people got a lot of fantastic insights. I know I did, and love the science side of everything. So everyone enjoy. Oh, sorry, John, you go.
I was just going to say one thing, Adam, that we can't scoot over. You've mentioned the AFL. We actually got to thank the curating staff at the Gabba and Gold Coast Stadium for what they did to keep the Southern game flowing throughout the winter months, and the awesome job those guys did. So real big pats on the back to those fellas. So well done.
Absolutely. And it just shows a lot of shared knowledge of the things I was hearing from those sectors, from the people in those sectors talking down south, and the sharing of the IP, which is helping this segment grow and more people are educated and aware. It's fantastic for this because, we all want our kids and families to enjoy great places to play, basically, and fields to play. So, exactly. Excellent. Definitely, John. Well, I thank you, everyone, for your time, and everyone have a great day, and we'll provide a recording in the near future. And, thanks again. Appreciate it. Enjoy, everyone.